In this presentation, I'll talk about swaps. Now, the general agenda is as follows. We'll first talk about plain vanilla interest rate swaps, which are the most basic kind of swaps and ones that have the highest probability of showing up on the exam. Then we'll talk about the characteristics of a swap. We'll then talk about currency swaps, equity swaps, and how to terminate a swap. I have taken the liberty of changing the order here a little bit relative to what you might see in the curriculum or what you might see in most study notes, and I think this flow will just make it easier for you to understand the topic. Another thing that I'll do is I will explain through examples. What a lot of study notes do is bombard you with definitions and jargon right up front, which is hard to retain. So I will just explain examples and talk about the jargon or the terminology through the examples. I think you will find that easier to absorb. So now, before we jump into a plain vanilla interest rate swap, I just want you to memorize this definition. So a swap is simply an agreement between two parties to exchange a series of cash flows. Okay, so just pause here and make sure you memorize this statement, and then this statement will basically flow through this whole presentation. Okay, the most basic kind of swap, and that's why it's named this, is the plain vanilla interest rate swap, and I'll explain this through a very simple example. Party A borrows $100,000 from Party B for 3 years at a floating rate, and Party B borrows $100,000 from A for 3 years at a fixed rate. So each party is going to give a series of cash flows to the other party, and essentially there is a swap of cash flows taking place. So we need to figure out who owes whom how much. First, let's draw a simple diagram to depict what's going on. So let's say this box represents Party A, and Party A is going to borrow $100,000 from B for 3 years at a floating rate, or the floating rate we are saying is LIBOR. So Party A is going to make floating rate payments. So we call Party A the floating rate pair. So Party A is going to make payments based on LIBOR. Party B is represented by this box. So this is Party B, and we say that Party B borrows $100,000 from Party A for 3 years at a fixed rate of 5%. So that means Party B is the fixed rate pair, and Party B is making a fixed payment of 5%. Now we are making this very simple. Let's say that both these payments need to be made on a yearly basis. So let's draw out a timeline also. So this is 0, year 1, end of year 2, and end of year 3. Now what's happening at time 0? Party A is borrowing $100,000 from B, and B is borrowing $100,000 from A. Now if we want to be silly, then A will give $100,000 to B, and B will give $100,000 to A. That doesn't really make any sense. So we simply net off and say that no payment is made by anyone at time 0. Okay. Then let's come to the end of period 1, which is over here. So let's make an assumption that at the start of year 1, so at this point, let's say that LIBOR for this period, which is essentially the rate at the beginning of the year, let's say that at the start of the period LIBOR is equal to 4%. Now this means that at the end of period 1, the floating rate pair, which is Party A, needs to make a payment of 4%, and the fixed rate pair, which is B, needs to make a payment of 5%. So let me write this down over here. So A needs to pay, so A, remember, is the floating rate. So A needs to pay 4%, and B is going to pay a fixed rate of 5%. So B has to pay 5%, and the 4% and 5% is based on the notional principal of 100,000. And remember, the rate of 4% is based on LIBOR at the start of period 1, which means the 1 year LIBOR at time 0. Now what's the net payment that happens? B needs to pay 5%, A needs to pay 4%, so the net is that B has to pay 5%. In our case, since the fixed rate is more than LIBOR, at the end of year 1, the party B has to pay, this should be 1%. So party B pays 1% of 100,000. So party B needs to make a payment of 1,000 to party A. Then at the end of year 2, payments are going to be again made based on LIBOR for this year. And for year 2, let's say that LIBOR at the start of the year was 5%. So let's just say LIBOR here at the start of year 2 was 5%. So that's the rate that will apply to the floating rate loan. And now essentially for year 2, A has to pay 5%. So A has to pay 5% and B also has to pay 5%. So the net impact is that there is zero payment from both sides for year 2. And then in year 3, let's say that you have that LIBOR at the beginning of year 3, which means over here, is equal to 6%. Then what's the payment that needs to happen at the end of year 3? A, which is the floating rate pair, will now pay 6%, and B, the fixed rate pair, as always, will pay 5%. So the net effect is that A, who's the floating rate pair, will have to pay 1% of our notional principal. So notice that all periods, the fixed rate pair, which is B, is paying a constant 5%, and then A is paying based on LIBOR, and depending on whether LIBOR is lower or higher than the fixed rate payment, so we figure out who pays whom. And notice that the net amount is being paid here. So when we talk about plain vanilla interest rate swaps, a few points to note. There is no swap of the notional principal at the beginning or the end, and when interest rates payments are made, they are made based on the net amount. So now, as I mentioned, let's just make sure we understand all the terminology. Notional principal is obvious. Notional principal is obviously the principal based on which we are calculating the actual payments. Some other terminology: settlement dates. So settlement dates are essentially the dates on which payments are made. So our first settlement date is the end of year 1. So end of year 1, B pays 1%. So this is a settlement date. End of year 2 is another settlement date in this simple example, and end of year 3 is another settlement date. And then the settlement periods, so that's settlement dates. The termination date of the swap is this date over here. This is where the swap ends. So this is a 3-year annual pay swap. The tenor of the swap is 3 years. The fixed rate pair is the party that is making a fixed rate payment. So in our example, that fixed rate pair is B. The floating rate pair is obviously A, because party A is making the floating rate payment based on LIBOR. When we talk about a swap rate, the swap rate is the rate that is being paid by the fixed rate pair. In our example, the swap rate is 5% because that is the amount that is being paid by the fixed rate pair, which is B. So that is a very simple interest rate swap. Now I'm going to introduce a formula that you will see in most study notes, and this formula looks complicated, but essentially it is what we just did. The formula that you will see will look something like this. So net fixed rate payment, so the net fixed rate payment is equal to, so this essentially means that the net payment made by the fixed rate pair. So this is equal to the swap fixed rate minus LIBOR at time t minus 1 multiplied by the number of days divided by 360. For swaps, we generally use a 360-day convention, and we say that 1 month is 30 days. So this multiplied by notional principal. So if you recall in the example that we just looked at, what's the net payment of the fixed rate pair for every period? Remember what we said earlier was that we have a simple 3-year annual pay swap, 0, 1, 2, 3. So let's say the net fixed rate payment at time t is equal to this. So that means what's the payment that has to be made? Let's just take the year 3 example. So if we say net fixed rate payment for year 3, so that's the payment that's made over here, is equal to the swap fixed rate, which in my example was 5%, minus the LIBOR at t minus 1, LIBOR at 0.2. Why LIBOR at 0.2? Because for year 3, the appropriate LIBOR rate to use is the rate at the beginning of year 3. So beginning of year 3 is this 0.2 over here, because beginning of year 3 is the same as end of year 2. So if you recall, we said that LIBOR over here was equal to 6%. So we said 5% minus 6% into number of days over 360. In this case, we are taking a full year. So we basically have 360 over 360 multiplied by our notional principal, which was 100,000. So basically we get minus 1% of 100,000. So we simply have a minus 1,000. So the fixed rate payment, or the fixed rate pair, has to pay minus 1,000. The minus simply means that now on this day the fixed rate pair will get 1,000. So if the payment is negative 1,000, that means that the fixed rate pair is receiving 1,000, and it's actually the floating rate pair who needs to make the payment. So this is the formula, and as you can see, the formula is fairly straightforward. Now let's apply what we have learned to a slightly more complicated situation where we have a quarter pay swap. So again, we are on interest rate swaps, and we have a situation where Bank A enters into a $100,000 quarter pay plain vanilla interest rate swap as the fixed rate pair at a fixed rate of 6%, and we are basing this on a 360-day year. The floating rate pair agrees to pay LIBOR plus 1%. So the floating rate payment is LIBOR plus 1%. So that 1% is the margin. Sometimes you might see this written as 100 basis points. Now we are told that the 90-day LIBOR is currently 4%, and then we are given what LIBOR turns out to be for the subsequent periods. This is a 6% swap. Why? Because the fixed rate is 6%. So how do we model this? Again, the simplest and most important thing to do first of all is to create the timeline. So time 0, 1, 2, 3 and 4. So these represent 4 quarters or 4 periods. The tenor of this swap is 1 year. The settlement dates are at the end of every quarter. Okay, so we need to now calculate the amount Bank A pays or receives on day 90. So day 90 is the end of first quarter, and then 270 is over here, 360 is over here. So essentially we need to calculate who pays whom how much on the various settlement dates. So first of all, let's look at the first period. Now the LIBOR initially is 4%. So LIBOR initially is 4%, but the floating rate pair, let's see who's the floating rate pair. So A enters into a 100,000 swap as the fixed rate pair. So in all these examples, we can figure out how much A is paying, and B is the floating rate pair. So we'll figure out how much B will pay and figure out the net difference. Remember from before that we don't exchange any cash flows at time 0. So at time end of period 1, A is going to pay 6%. Now this is a annualized number. We need to bring this down to 1 quarter. So essentially A will pay 6% for the year, but this is for 1 quarter. So multiply by 90 over 360, which means 6 over 4, which means A is going to pay 1.5%. What about party B? Party B now, remember, is the floating rate pair. So party B's payment is based on LIBOR at the start of the period. LIBOR at the start of the period was 4%, but we are adding a 1% margin, so that makes us 5%. 5% into 360 into 90 over 360 means 5 divided by 4. So party B is going to pay 1.25%. So what's the net effect? The net effect is that A has to pay 0.25% of the notional principal. Now just to save space here, you can now figure out, so this is the payment that needs to be made on the first settlement date. So A, given this LIBOR, A needs to make this payment. You can now figure out who needs to pay whom how much on this date. I am going to just do this calculation for you to make it, just in case you've not understood the point fully yet. So again, on this settlement date, which is the end of period 3, A as always is going to pay 1.5%. How much will B pay? The amount B pays depends on LIBOR at the beginning of this period. So LIBOR at the beginning of period 2 is LIBOR. So this period 2 means this is like day 180. So we are told that the LIBOR 180 days from today is 5%. So since LIBOR is 5% and we are adding a 1% margin, B needs to pay 6%, but this is on a quarterly basis, so we divide by 4. So 6 over 4%, so this is equal to 1.5. So we notice that for this period 3, nobody pays anyone because the two net out. So hopefully you understood that. Now for the second period and the fourth period, I want you to calculate how much A will pay, how much B needs to pay, and then what is the net amount. So this should not be very hard. You can also essentially use the formula on the previous page. Here is a simple example and quite indicative of what you might see on the exam. Let's say you are given this picture and you are told that we have two parties. So counterparty A, which makes a fixed payment, and you have counterparty B, which makes a variable or a floating rate payment. Now, which of these statements is true? A will benefit when interest rates increase. So when interest rates increase, then A will benefit because A needs to, let's say A's fixed rate is 5%. So if interest rates go up, party A is still paying 5%, but party B will have to now pay a higher percent. So if interest rates originally were 5%, but now they have gone up to 7%. So clearly the net payment to party A is going to be more. So this is correct. B pays a fixed rate to counterparty A. This we can see is clearly wrong because this arrow is showing a variable rate. So this is not correct. B will benefit when interest rates rise. That we can also see is not correct because when interest rates go up, then B is paying a higher rate, but B is still only receiving 5%. So this is also wrong. So clearly the correct answer is A. Now that you've understood the most basic kind of swap, let's just understand what are some characteristics of swap contracts. Swap contracts are custom instruments and they are not traded in an organized secondary market. So if you want to get into a swap contract, you go to an entity called a swap facilitator who might either find a counterparty for you or might take the opposite position from you. So swap facilitators would typically be financial institutions. In Pakistan, the authorized derivative dealers can take a counterparty position. So if you are, let's say you are a energy company and you've taken a huge floating rate loan, and you want to essentially convert that into a fixed rate, what you can do is get into a swap contract with the authorized derivative dealer. Let's say you get into, so this is party A, that's you can get into a swap contract with party with the authorized derivative dealer, and then typically this authorized derivative dealer will then get into a contract with another party where it's taking the opposite position. So if, for example, you over here, so this is you get into this position where you are making fixed rate payments and receiving float, then typically what the entity in the middle will try to do is take an opposite position with somebody else. So with the other counterparty, what UBL might do is, since it's receiving fixed over here UBL might pay fixed and receive float. So anyway, this is just a simple example. The larger point is that the swap contracts are not traded on an exchange. They are private contracts between various large entities, and the party that sort of facilitates swaps is called a swap facilitator. This is mostly an unregulated market. Obviously, default risk or credit risk is a concern. Since we don't have an exchange or a clearinghouse in the middle, you can have any party that needs to make a payment can possibly default. Generally, it is large institutions that participate in swap contracts. These are private agreements, and once you have a swap contract, it's generally difficult to alter or terminate. Nothing too radical over here. As long as you understand and memorize these points related to swap contracts, you are in good shape. So notice now that in terms of this material, swaps are sort of like forward contracts. So very briefly, swaps and forward contracts are generally custom instruments, whereas options and futures are exchange traded. So these are exchange traded, and generally swaps and forwards are over the counter. I also want to emphasize that there is a similarity between swaps and forward rate agreements, and the term that you need to memorize is that a swap is simply like a series of forward rate agreements. So let's take a very simple example. Let's look at this swap. So let's go back to the first example that I talked about, where we have a 3-year annual pay swap. And let's say you take the position of a fixed rate pair, and you are just paying for every period, you are making a payment of 5%. Okay, so for period 1 you make a payment of 5%, for period 2 you make a payment of 5%, and for period 3 you are making a payment of 5%. And now obviously this 5% needs to be compared with LIBOR. Essentially what is happening is, if you are the fixed rate pair, and let's say that LIBOR for this period was equal to 6%, and then actually let's just assume that initially LIBOR is 5%, and then in the subsequent periods, let's say LIBOR goes up. So for this period, let's say LIBOR becomes 6%, and then for year 3, let's say LIBOR is 7%. Then you as the fixed rate pair will actually be happy, because even though the market rate is going up, but because you have this swap agreement, you are only paying 5%. Now notice that this single swap contract is essentially equivalent to 2 forward rate agreements. So again, if I draw the same timeline, what we could say is that if you have one forward rate agreement for this period, where if you go back to your FRA terminology, this you could write as a forward rate agreement which starts at the end of year 1 or period 1 and goes till the end of period 2. So, and let's say that the contract percent is 5%. Plus, you get into another forward contract for this period where this FRA starts at the end of period 2 and goes till the end of period 3. So that's a 2/3 FRA, and the rate there is also 5%. So the combination of this series of forward rate agreements effectively guarantees that you are paying 5% for these periods, just the way the swap guaranteed that you are paying 5%. So that illustrates the fact that a swap is like a series of forward rate agreements. What are some other similarities? Typically with both forwards and with swaps, there is no payment made at initiation. As we've already discussed, swaps are generally customized agreements between two large institutions, and they are not exchange traded. These are generally unregulated, and obviously there is some default risk / credit risk because your counterparty might not fulfill its obligation.